really happy to be with you in this session. So I will be starting and then I will give the word back to Lorena. I'm Innovation Unit Leader in IRIS, which is an engineering company located in Spain. And we have been working on circularity of plastic and bio-based plastics from waste byproducts for a number of years, and I'm happy to tell you a little bit of introduction regarding the issue of recycling of packaging and plastic in general, before then going into more detailed discussion on why is it more complex when it comes to multi-layer packaging. So you can go to the next slide, Nina, please. Well, first, starting by status quo on the use of plastic and some figures. I mean, we are all aware that plastic are being used in a number of applications. The demand in Europe is huge, like in the range of 50 million tons per year. And packaging is the main consumer of this amount of plastic because it's a very short-term use, and a lot of convenience products actually choose packaging as the key material due to its lightweight, versatility, and so on. But yeah, plastic are everywhere, but really everywhere, meaning that more and more it's found in places where it shouldn't be. And this has raised a lot of mediatic concern and public concern in the last year, as we are all aware. So maybe Nina, can you go to the next slide? As an answer to this concern, well, the European Commission has set different legislations, and one of the most meaningful one in the recent years is the European strategy for plastic in a circular economy that came into force beginning of last year, and includes a number of different measures and targets for the future. One of them can be as bad as the banning of plastic for certain application. When I say as bad as is because I'm a plastic specialist, so of course finding an alternative material is not always maybe what would be preferred, but the single-use plastic is not applicable to packaging. So in the case of packaging, what this strategy says is that by 2030, we should have all the packaging put on the market being recyclable by design. And the recycling of packaging should have reached before this year a minimum of 55%. So all those rules are targeted to make recycling more profitable as a business, and also to drive different investment and innovation around these issues. Next slide, please, Nina. So how do we stand towards this target for 2030? Well, some people would say not so bad or good. We are at the moment, according to the plastic sector industry, in the range of 32% of the plastic put in the market in Europe recycled. This is twice as much as 12 years ago, so it's convincing and encouraging evolution. But still, there are in the range of 40% going into energy recovery and 25% going to landfill, according to these figures. In the case of packaging, which is the core of our focus here, the recycling goes up to 42%, according to this figure. But Nina, next slide, please. If we look at wider figures, so globally, and figures which take into account not only the waste plastic that end up in controlled conditions, so that are managed and collected well, we actually see much more alarming figures, because as much as 32% of the plastic packaging actually leak in the environment in some ways. This is in addition to the 40% going into landfill, 14% going into incineration. So all those are actually not capturing the value that we put in the first life of the material that we are producing. And according to these figures, only 14% is going to recycling, but a lot of the recycling is not even in closed loop. So closed loop recycling, meaning able to serve an application that is as good as the first life, as demanding as the first life, is according to this number only 2%, because then there are also cascading recycling going to lower end applications. Well, we are far from circularity, but let's look at how it's going on currently for, let's say, best practice in terms of packaging. So we'll look at a simple example, simple monomaterial example, which are the PET bottles. So we start from having virgin materials being used by producer in order to get the bottles, which end up as post-consumer waste, which are finally collected and sorted in sorting center, then served back to recyclers, which are able to with this mono fraction, to wash them, grind them, extrude them back. In some cases in closed loop, meaning going back to PET bottle, even for new food contact application. And in many well-established cases, also for other applications. For example, in textile, there is a lot of recycled PET that we can find. But this is one of the best cases where the food packaging can go back into the similar food chain. But let's ask to Lorena a bit, how is it? How is the case when we talk about more complex materials and multi-layer material? If you can go to the next slide, Nina.
Next slide. Okay, so when we have a multi-layer material, then the scenario changes a little bit in comparison with monomaterials. For example, the example that already Elodie has shown us in relation with PET bottles. So the figures here change a little bit. When we think about plastic packaging, if we see the overall market, we can say that it has been divided very flexible and rigid. When we think about monolayers, then there is a very high amount of material that is around 80% of packaging material are monolayer, and then when we think about multi-layer, it is around 12–14% in relation with. Okay, but the fact is that there are a lot of products that need to be packaged in using multi-layer materials, and this is based on one of the things that I already have said before. The barrier packagings, the barrier properties are really important to be assured, because one of the main target of our packaging solution is to protect the product that is inside. So we need to think if one material it's enough to protect the product, or if we need different materials for solving that problem. So here we have another figure in relation with which are the most common plastic material that we use in packaging. Next slide, Nina. But the thing is that apart from that, there is a point on barrier packaging that we need to think about. Okay, so the figures that I saw already, the multi-layer packaging material, they are not going to be reduced. Why? Because the global market for barrier packaging is growing, and the expected growing is at 8% in the coming years. So that means that even if we improve our materials, we always need to think about using complex packaging structures in order to obtain the final packaging that we need. Okay, next slide. So that means that at the end that we are going to need to continue using different multi-layer packaging structures. It will depend on the packaging of the food product that we are going to package. We are thinking about food product. This is the point of this slide. So We know that there is not a unique material that has all the properties that we need for our final packaging. So that means that we need an external layer for structure properties, that we need an inner layer for barrier properties, and then another layer for the sealing properties. So at the end, we need at least 3 different materials, and normally we need sealants or tie layers to be able to link different materials, because they are not compatible and they cannot be linked without any sealant. Okay, so at the end, we need to think that in some cases we could try to reduce the cell life of our products. In some cases, we will improve the barrier properties of monomaterials. But the fact is that at the end, for different approaches, for different solutions, we are going to continue working on multi-layer packaging structure. So, and apart from that, some years ago, multi-layer packaging structure started growing because the first point of trying to reduce the environmental problem with the packaging, it was to reduce the thickness of the structure. So we try to obtain multi-layer packaging structure by reducing the thickness of the final packaging. Okay, so at the end, it's true that in the case of food packaging applications, we have approximately 70% of packaging structures are multi-layer materials. Next slide. Here is just a slide where we can see that there are many materials when we think about mechanical, the structural layer or the barrier layer or water vapor barrier layer. So it's like there is a huge number of different materials that we need to use in our multi-layer packaging structure. They are from different natures, and they need to be handled in the right way in order to create a good recycling flow for multi-layer materials. Next slide. So one of the things that, or the first step, it is to divide, the Association of Packaging Market has been dividing the most common multi-layer packaging solution in 5 different categories in order to understand how they work, and trying also to develop different strategies to be able to work with them and trying to recycle them. So these 5 categories made up close to 20 billion square meter, approximately close to 2 million tonnelates. Okay, and this sum approximately the 50% of square meter of the plastic-based flexible packaging. Next slide. So first step is to understand which are the most common packaging structure, which are the deal that we need to solve, and what we need to do. Okay, in the left part of the screen, you could see a standard sorting plant, and the thing is that we see this standard sorting plant, and we talk about multi-layer flexible packaging. We enter a flow of multi-layer flexible packaging. The standard sorting plant is not able to separate that material, and we will end with a mix of plastic film. Okay, so there are a lot of things that we need to do in order to prepare our plants to be able to recycle multi-layer materials. There are a lot of things that are, a lot of studies and a lot of projects in relation, and basically they are working with separating the different components. Some of them are using mechanical delamination and also chemical delamination and also physical delamination. But the thing is that at the end, there is a lack of sorting standard techniques that for this kind of material, and also a lack of industry for separating and recycling this material. So the next slide, it's about different projects that AIMPLAS and also IRIS are involved to show you some developments that are going on in relation with trying to obtain multi-layer structures for being recyclable. So the first solution is it's a European project. It's a live European project that AIMPLAS is involved, and it's the idea of this project is to obtain a high quality material from a non-recyclable plastic waste. We are working not only with packaging, flexible packaging materials, but also with different waste like electrical and electronic and also automotive sector. There we are using the chemical recycling to obtain the material, and the idea or the final target is the reduction of the non-recyclable plastic flow to avoid their waste in the landfill. Okay, next slide. Next slide. Okay, so
Lorena, sorry to interrupt. I just want to keep in mind on the time because we're running out, and we want to make sure we have some time for the discussion.
Okay, so I can go then. So I can go to the next. So I'm going to be faster. So then my colleague Elodie. So we are also been working in different recycling methodologies for obtaining polyamide from food packaging multi-layer films. This project, in this case, we have been working in the lamination process for the PA. And also for compatibilization process for the polyamide and being reprocessing to obtain a food packaging material that can be used in packaging structures. And then our last project, it's about, next slide, Nina, sorry. Our last project, it's about new solutions based on PBOH. PBOH is a soluble material, so we have been working in developing new structures based on PBOH to use instead of EVO, which is not a soluble material. So we have been doing a lot of eco design in that part, and also we have been working in recycling them, separating them in order to obtain materials that can be used again for the food packaging industry. Next slide. So this is next slide, Nina. So this is what already has told you, and I will pass the word to Elodie, who will show some of the project they are also working on.
Thanks a lot, Lorena. So Lorena just told you about solution which allows the delamination of multi-layer packaging as an enabler for recycling, and I will continue on the similar type of approach, but here leveraging on bio-based coatings for allowing this delamination of multi-layer films. And we will come back to the issue that was mentioned earlier by Tristan about whey protein. So we used actually whey protein, which is a byproduct from cheese production, in order to replace EVOH in multi-layer film, because it's an non-avoidable waste, which is not totally currently used, and actually the use we do is only for one of the fraction, the protein. It's still compatible with the use for live stock feeding, because the most important fraction for them is another one, the lactose and the liquids. But anyway, just that was to come back on the previous comment. So here what we did is developing a coating that can be applied on different layers, and has been validated for packing different types of foods, also different types of cosmetic and pharmaceutical product, and as a barrier to oxygen, which is approaching the level that EVOH can have. Next slide. Now focusing on the end of life that is possible with this new material. So, well, they are different and customizable to the structure where the coating is applied, but basically the main aim is when applied to standard polymers, I will reply to the question popping up. It can be used in order to separate the layers thanks to an enzymatic removal. So using enzymatic detergent in the bath of the recycler, we have a separation, an automatic separation of the different materials that then can be separated, for example, by density, and when separated, recycled separately. One added value also of this coating is that it's very well detectable by infrared, so that in the sorting it's allowing to have this multi-layer being picked out of the mass. After this reprocessing, we observe minor loss of properties, so the materials would be fit for reuse in packaging. When we would be applying the same coating on biodegradable substrates, so for example on PLA, we are able to obtain compostable packaging and the end of life with enhanced barrier properties. Can you click, Nina? And we are currently working on a new project called Bio on Top. Sorry, just click. Can you go back? Can you go back?
Sorry, Elodie.
Yeah, we are currently working on a new project where we are on the one hand side upscaling the recycling of the material recovery, but also we are working on home compostable solution where this coating is applied. You can go to the next slide, and this coating is applicable both on flexible and rigid packaging. So we have different grades depending if we need thermoforming or not. So this was in order to develop new materials and eco-design solutions for future packaging, but we are also dealing in other projects. One is called Multicycle, with solution for the current conventional fossil-based multi-materials. So there we are using a technology called Creasolve, which is based on preferential solvent-based extraction of the different polymers which are making up the multi-layer. While we are upscaling this technology in this project. You can go to the next slide as I will try to go quick. And there we are dealing with different aspects, such as being able to monitor the composition of the waste which is entering to the process in order to optimize the process accordingly, like the choice of the solvent, the process condition, and so on and so forth. And with this process, we are able to recover polymer, but also when included in the waste fraction, fibers, for example, from composites. And really importantly, this process doesn't downgrade the properties of the material, so it's allowing reuse in similar application. You can go to the next slide. Nina, so I think we are getting to the conclusion on this presentation. So with Lorena, we have tried to show you different initiatives that are ongoing in order to increase and improve the circularity of multi-layer packaging, as it will be important also that this category of packaging are recycled in order to meet the future target of the European Commission. And as in terms of material, there is no one material fits all. There is not also one recycling approach that fits all. So that's why we have seen different approaches, from organic recycling to pyrolysis to delamination, and all can make the small stone in order to reach the goal. I think we have finalized. Thank you very much for your attention.